All right, we are going to look at systems of equations, and we'll start with this paper here. Systems of equations are two or more equations, or could be linear functions. Today, we're just going to be looking at two linear functions. So types of solutions here, if I were to draw two linear functions here, you could have, and this is just an example, two lines, and where those two lines cross is one solution, right? So you could have one solution. You could have no solution, which results in two parallel lines. So if it's no solutions, they would be parallel. And then here, if you have infinite solutions, that means that your two lines are exactly the same line. So you could have one solution where they cross at one spot, which is going to be the majority of what we're doing today. Then you could have parallel lines where they do not cross at all. That means no solution. Or you could have two lines that are on top of each other, and so that all of their solutions are exactly the same. So we are going to first start by solving by graphing. There are three methods for solving. Here's our first method, solving by graphing. Now, notice that my lines are written in y equals mx plus b. So that's our goal, is to get it into y equals mx plus b. Here they're already written in y equals mx plus b. So I want to identify first what is our slope and what is our y-intercept. So this first one, our slope is -5/3, and our y-intercept is 0, -6, right? For the second one, our slope is 1/6, and our y-intercept is 0, 5. So for my first line, I'm going to start at this 0, -6, 2, 3, 4, 5, 6 right here. It's like the numbers are off. And then I'm going to count my slope down 5/3. Well, I'm going to go off my graph. So I'm going to go up 5, 1, 2, 3, 4, 5, and back 3. So I have a negative slope, 1, 2, 3, 4, 5, 1, 2, 3. 1, 2, 3, 4, 5, 1, 2, 3. All right, so this is my line here. Get my straight edge. So, draw my straight line. All right, and then let's draw our other line. So I'm going to start at 0, 5, 1, 2, 3, 4, 5, and then count my slope up 1/6. So rise 1, 1, 2, 3, 4, 5, 6, run 6. I'm going to go down and back as well. 1, 1, 2, 3, 4, 5, 6. Oh, that's cool. They have overlapping. So in this system of equations, we have exactly one solution. And if you notice, they cross at this point. So this point is -6, 4. So my solution here is -6, 4. So the solution of your systems is where your two lines are going to intersect. Let's try another one. Let's try number 2. It's already written in y equals mx plus b for us. Now, if you notice this one, y equals 5, this is a horizontal line. We've done one of these before. 1, 2, 3, 4, 5. I'm going to find 5 on my y-axis. And then I'm going to draw a straight line, straight horizontal line through 5. And then we're going to draw this other line. So let's identify our slope and y-intercept. Our slope is 2. And remember, rise over run is 2/1. And then our y-intercept is 0, 7. So I'm going to find 0, 7. And then I'm going to rise 2, run 1. And I'm going to go down and back 1, down and back 1. Until I get enough points to draw a line. Down 2, back 1. Sorry, not down 1. And it looks like I have one solution. Again, that's my solution there. And this solution is x first, then y. So it's -1, 5. And it's a point, -1, 5 is my solution. All right, let's try number 3. If you notice on number 3 that neither of them are written in y equals mx plus b. So my first goal is to write them in y equals mx plus b. So I'm going to do it on this piece of paper just so I have enough room. So we have 6x minus 5y equals negative 45. And we took notes on this back in your journal about graphing linear equations. Subtract your x value is our first step. So we have negative 5y equals negative 6x minus 45. And then divide by negative 5. So when you divide by that negative, you have positive here, because negative divided by negative is a positive 6 over 5x. Negative divided by negative is a positive 9. So I'm going to rewrite this as y equals 6/5 x plus 9, where my slope is 6 over 5, and my y-intercept is 0, 9. And then let's do the next one, under it, that 2x plus 2y equals negative 4. So solving for y, subtract 2x. So we have 2y equals negative 2x minus 4. And then divide by 2. That cancels. Y equals negative 2 divided by positive 2 is negative 1x. Negative 4 divided by positive 2 is negative 2. So rewrite it in slope intercept form, and our slope would be negative 1. And if I make that into rise over run, it's negative 1 over 1. And then my b value is 0, negative 2. So now we're okay to graph this. I'm going to find 0, 9, and then count my slope up 6 over 5. Well, that goes off. So I'm going to go down 6 and back 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So little. All right, so connecting our dots here. All right, that's that one. Now let's do the next one, starting at 0, negative 2, and then counting down 1 over 1. Up 1, back 1. So I do meet. That's good. Draw my line. Crooked. Very crooked. That's not good. But I do see that they cross here. So this intersection point is negative 5, 3. So my solution is negative 5, 3. I have 1 again. That's great. So let's flip it and we'll talk about solving by substitution. We're going to do a couple of these. This is our next page. Solve one equation for x or y. So we're going to isolate a variable, and then we're going to substitute into the next equation. So I like to write these next to each other first, and then substitute. So it looks like they're both already solved for a variable, so that's good. So I'm going to say, okay, if y equals negative 7x minus 1 here, then y equals negative 7x minus 1 there. So I'm going to plug in negative 7x minus 1 into y. So we have negative 7x minus 1 equals x minus 9. So all I did was replace this y with negative 7x minus 1. Now I have one variable. I can solve the equation just like a regular equation. So let's add our 7x to the other side. So we have negative 1 equals 8x minus 9. I'm going to get my 9 on the other side by adding. So we have 8 equals 8x. Divide, and x equals 1. All right, so we have one value. Now that we found our x value, I'm going to take this x and plug it back into one of the original equations. I'm going to plug it back into this first one. Negative 7 times 1 minus 1. Negative 7 times 1 is negative 7 minus 1. Y equals negative 8. So we have an x value and a y value. I'm going to write my solution as a point. So my x value is 1. And my y value is negative 8. You probably are remembering this from Algebra 1. All right, let's look at number 8. I have y equals negative 5x plus 30. and 7x plus 3y equals 42. So my first step is to isolate a variable, to get one variable on one side and everything else on the other. Looks like we have solved for y. Y is on this side, everything else is on this side. So that's good. I'm going to take what y equals and plug it into the y in the other equation. So instead of y, I'm going to write negative 5x plus 30. Notice that I put it in parentheses so I can distribute this 3 because we're multiplying, right? 3 and y are being multiplied. That means I'm going to multiply 3 times y. So we have 7x minus 15x plus 90 equals 42. Combine our like terms here. Negative 8x plus 90 equals 42. Subtract our constant. Negative 8x equals 8. Let's see. 8 minus 4, 48. Yeah, negative 48. Divide by negative 8, and x equals 6. That's great. So now that we have our x value, we're going to go back to the original equation and plug it back in. Y equals negative 5 times 6 plus 30. Negative 5 times 6 is negative 30 plus 30 is 0. So we have an x value, a y value. I'm going to write my solution as a 0.60. All right, that was 2 where they were already solved for a variable. Let's look at this number 9. I'm going to write them next to each other, and let's look and see if one of the variables is already solved for. And I already see, because I'm looking for a variable on one side and everything else on the other side, and I don't see that. However, I do see a variable alone. So I'm looking for a variable that doesn't have a number in front. And if you notice, this y value only has a 1 in front. It doesn't have a number in front. This is the easiest one to solve for. So I'm going to solve for this y. So that means I want y on one side, everything else on the other side. So that means I need to get rid of the 7x by subtracting. So we have y equals 22 minus 7x. Now I'm solved. So if y equals 22 minus 7x here, then y equals 22 minus 7x here. So we're going to plug in 22 minus 7x instead of y there. Running out of room a little bit. Distribute this negative 5. Don't forget that it's a negative. Negative 5 times 22 is 110, 110. And then negative 5 times negative 7 is positive 35x equals negative 28. All right, combine our like terms. 35 and 6 is 41. Man, I hope we get a good number here. And then add 110 on both sides. So we have 110, 82. Oh, that is a good number. So we have 41x equals 82. Divide by 41. And x equals 2. So that's great. We found our x value. So once you find one of your variables, you're going to take it and plug it into the other equation. Minus 7 times 2. So 7 times 2 is 14. 22 minus 14 is 8. So we have an x value, a y value. Our solution is 2, 8. That's great. All right, let's do one more like that, and then I'll let you practice on delta math. I'm going to write them next to each other. 7y equals 53. Negative 4x minus 5y equals 19. So they're not solved for a variable already. However, I do see I'm looking for a variable that's alone, right? So that doesn't have a number on front. So I'm going to solve for this x by getting rid of the negative 7y by adding 7y on both sides. So we have x equals 53 plus 7y. Now I've solved for a variable. On the other ones we've solved for y. It doesn't matter which one that you solve for. I like to solve for the easier one, and the easier one is the one that has the variable with no coefficient, right? Or that the coefficient is 1. So if x equals 53 plus 7y here, then x will equal 53 plus 7y there. So I'm going to plug in 53 plus 7y minus 5y equals 19. Distribute negative 4. Oh, these are going to be big numbers. 4 times 53 is 212, and it's a negative 212. 4 times 7 is 28, minus 5y equals 19. Let's combine our like terms. Negative 212, and that's going to be a negative 33y equals 19. Add our constant to the other side. 19 and 212 is what, 231? I'm going to check my math there. Plus 19. 231. All right. Equals negative 33y. And let's divide by that negative 33. So 231 divided by 33. Oh, good. 7. That's good news. Y equals negative 7. I was worried there. All right. So once we've found one variable, we're going to plug it back into the original equation to find the other variable. So x equals 53 plus 7 times our y value 7. So that's 53 minus 49, because positive 7 times negative 7 is negative 49. And 53 minus 49, it's a good number, it's 4. So we have a x value, we have a y value. We're going to write it as a point for our solution. And our solution is 4, negative 7. All right. So please put these notes into your journal and begin practice on your Delta math. And I will see you when I get back. Have a great weekend.